So I believe the cardioid we had before was this. Uh-oh. I don't remember it. Sorry, I thought I did. This cardioid, if I could skip how to sketch it out completely because we've already discussed it. It's going to open up this way. So let's see if you and I can compute the entire length of that cardioid. Obviously, there's symmetry. So if you don't mind, I'm going to just integrate the 0 to pi and double the result. And the length of the cardioid then can be computed as such, 2 times this definite interval. So I can give you this. Oh, my pen's dying. Wow, 1 pen left for the entire semester. Now, when I combine these two terms, that's going to give me a positive 9. Added to that 9 is going to give me an 18. Pull the 18 out of the square root is going to give me a 3 root 2. Combine it with a factor 2 is going to give me a 6 root 2. And the radicand's position, I'm left with so would you mind if I yet again stall for a minute? Can I just double check arithmetic? So I see, I like it, yes, yes. And that's a 3 root 2. Okay, I'm happy with it. So next on my list, I don't know if you see how to integrate this. But I'm not feeling too comfortable with my board space, so if you don't mind, in case you don't immediately see what to do next, let me jog your memory a little bit. Pulling out a nifty piece of scratch paper. Now, if you don't mind, I'm going to suppress the sign change. I'm dealing with a positive square root, or a principal square root. So check this out. So this is what I have in the integrand's position, albeit with the change the name of the variable. Who cares about that? And so doesn't that imply that I can replace a radical, all that garbage, with this? Again, replacing x with a zeta. So I can give me this. Here too, time for another break. Looks good. Now let's evaluate. No, you know what? I made a mistake. My apologies. I'm doing too much in my head. Let me show my steps. So negative 24 times a cosine of actually pi halves, in my head that has a pi, minus the cosine of 0 radians. But that actually is just going to give me a positive 24 because the first term immediately goes to 0. My apologies, but at least I caught it. Oh, shoot, before I go. It is indeed the case that I expect you to be able to clearly sketch a polar graph. And I have now just developed these 3 new tools computing slopes of tangent lines, area, and arc length describing polar graphs. So here are the tools that you need for calculus with polar graphs. And this means for the entire semester, we're done with the calculus. I've only got a couple topics to discuss, but they do not involve any calculus. It's just review some basic trigonometry.